I'm sure you've seen on the news the recent increase in PMD-related accidents. PMDs share a common pathway with other pedestrians, and accidents have proven to be fatal, even resulting in death. In an attempt to prevent this issue, LTA believes that scooters should be limited to 10 km per hour on pathways, crippling PMD users to a near jogging speed, affecting users, especially those who rely on these devices as a source of income for food delivery. Our team at SG Dynamics believes in creating a real solution for this problem. Introducing the Dynamic Speed Limiting System.
The system consists of three major components: the main control servers, the monitoring stations, as well as the transceivers installed in the PMDs. Transceivers are tamper-proof plug-and-play modules to be installed on every PMD in Singapore. It is connected to the scooter's speed controller and receives radio signals to make adjustments to the maximum allowable PMD speed. Monitoring stations are positioned strategically island-wide where necessary to allow authorities a full range of control over the PMDs in a specific zone. Monitoring stations perform two functions, namely signal broadcasting as well as human density monitoring. Signals are broadcast from stations in a user-defined radius to control the maximum speed of all PMDs in the area. The cameras mounted on board the stations perform human density monitoring functions, and using a specially designed algorithm performs real-time speed adjustments to the maximum speed of PMDs in the area. The speed of PMDs can be controlled to the point where the user is required to dismount and push at high human density or accident-prone areas. Next, we have the main control servers, otherwise known as the Overwatch system. The Overwatch system displays the serviceability status of all monitoring stations island-wide. It also provides the authority with real-time information of hotspots where an increased activity of errant users occur. This reduces the need to station enforcement officers at the location, but only deploy where necessary, significantly cutting down the manpower required. Errant users such as those without transceivers installed and speeding will be captured for the authorities to take the necessary enforcement action.
We will now show you our system in action. Here you can see the typical park connector shared pathway in Singapore. The user control robot represents the scooter and has the transceiver on board. The PMD is now travelling at maximum speed. This screen shows the live footage as seen from the monitoring stations on the Overwatch system. As you can see, a human is now being added into the view of the camera. The monitoring station detects the increase in human density and performs a speed limitation of the PMD in the area. As you can see, despite the user attempting to apply maximum throttle, the PMD's speed is limited. Next, another human will be added into the monitoring station's camera view. In this scenario, with an increase in human density, the monitoring station uses a specially designed algorithm to cut the PMD speed completely. In this case, the PMD user would have no choice but to dismount and push as the safer option. Here is a closer view of the monitoring station with the camera mounted. This self-sustaining station is completely modular and can be mounted on any existing lampposts or surfaces. With this, we have come to an end. Our team at SG Dynamics believes that this system is the only solution to a safe journey for all.